Well, good morning, fellow telco warriors. And I got what is going on out there. You know, every morning I wake up in Silicon Valley, something new has been invented. You know, there's a new large language model. There is a new robot coming out. There is a new quantum capability being launched. And it's just something which is accelerating at a speed. Well, I'm wondering what's really in for us from a telco point of view. So I thought, you know what, to set the scene for the day today, what I'll do is I'll talk you through a typical day of mine, the engineering exercises we do in the basement, then what it really means, what's the impact on the network, and then the opportunities going forward and what we need to do from a 6G point of view. And hopefully I'll inspire some of you researchers to focus on some of the challenges we have ahead. So let's get it going. So what's the market trend? And, you know, that is a slide which, you know, I could have presented perfectly 10 years ago, but it was a PowerPoint back then. Now it's real engineering. We're actually doing the integrations, 5G into all waters here. Let me start with the industry side. Something I'm super excited about is my 5G connected laptop. I actually own one. I can work now where I want, on the run, train station, in the plane, airport, in the office, at home. Don't have to worry about Wi-Fi. Don't have to worry about security. This was a 3 years project in making with Dell, Microsoft, Qualcomm. So it's a super exciting thing which is currently taken off. So let's see how this picks up. Another one which completely surprised us is autonomous vehicles. You know, we thought autonomous means they're going to be driving on their own. They don't need the network because they're actually processing everything on the vehicle. Turns out the opposite is true. We got some real data now from Austin, and you know, just 4 or 5 of these turning up in the same sector, completely maxed out the uplink, and we're like, hey, what is going on here? So we started to really examine what AVs are actually doing. Turns out they're pumping a lot of data in the uplink, not least to get training data, but also because the insurance markets require that, as well as for another set of reasons if you want to get it out of a little traffic jam and it doesn't know what to do. So this is a use case we did actually not even cater for. We've kind of had it always on the wish list, but deep down we thought it will never really materialize. It's here. It's here, it's now, and it's a data tsunami. Same with the droids. I personally help a few droid companies within 5 minutes driving from my office, connect them to 5G. And the data rate they're pumping in the uplink is equally crazy simply because they need cameras, they have insurance reasons, data training, etc. So whilst it will not remain at these 100 megabits per second we see now per droid, but even if it goes to 10 meg or 1 meg and the amount of droids scales up to hundreds and thousands, we have a huge data problem. So this is coming, this is real. And the consumer market isn't sleeping either. Mobile phones won't disappear. We're still using it. New devices like augmented reality is coming. So we have our friends from Qualcomm here, which are really driving this, at a phenomenal speed. And then we have agents. I'm not sure anybody using an agent on their mobile phone. Just hands up. So I recommend you download something called Pine. It works in the United States. It's a small app on the App Store. You actually can have it call on your behalf the utility companies, mobile operators, any troubles you have. It spends hours and hours on the phone with an eternal patience, which I don't have. So I love that one. This is my new best friend. And, this will basically really, really take off. So in a nutshell, that market is moving. Why is it moving now? So things usually move when 2 or 3 of very, very big ecosystems align. And this is happening right now, 25, 26, going forward. So the first ecosystem is networks. This is why we're here, but we're not the only one. There's devices as well. Some of us in the room on this one here, Qualcomm being a predominant example. And then, of course, the applications. We don't talk enough about this, but these are kind of 3 constituents you really need to take things off. Look at the iPhone. The smartphone has been around before Steve Jobs launched it. Right? So it's just, there wasn't an application. We had the network, we had the device, but we didn't have the application, didn't take off. Steve Jobs comes along, and he didn't even want to have the App Store. He needed to be convinced to implement it and introduce it. The rest is history. Really took off. Google Glasses, we had Google Glasses, 2010, 11. I love them. I think it's a very sleek design. It didn't take off because there's no applications. So we're now revamping the whole thing. Took us 10 years to get this right, but it's finally happening. And AI, of course, acts as an accelerant. So I thought, let me talk you through some of the constituents. So the networks, it's there. Ericsson took some, early decisions, strategic decisions, recognizing two or three things. I have two on the slide. One is uplink is going to be really important. So we started to invest heavily into an uplink portfolio. Specifically, the mundane issues we've been working on from a research community point of view for ages now. Looking here, my good friend Robert Heath, of course, he's been, preaching and really driving this field for years, talking about carrier aggregation, multi-user MIMO, uplink comp, etc., distributed antenna arrays in the uplink, something I had co-pioneered more than 20 years ago. So, it takes time for all that academic innovation to come in, but it's important. So it's important you continue innovating because we'll hit eventually, billions of end users at some point. So there's a lot of stuff there. So we have a lot of software features, interesting hardware features as well. We just discovered a little glitch in the PIM design of antennas, and it turns out without upgrading any hardware or software, our customers can now enjoy another 2-3 dB in uplink capacity simply by doing a little tweak on the passive antenna. This is really, it's rocket science and not rocket science. It's hugely important, very cheap upgrade. 3 dB in the uplink means you get, probably 50% more cell coverage, which is phenomenal. So hugely important. We have a huge portfolio, works really well. But the other thing we did is we also doubled down on AI. We are a bit of a quiet player when it comes to AI. But when we do it right. We took the decision to open up our network through the Open RAN specifications. We actually implemented. We're the only vendor that actually commercially implemented Open RAN. Open up on the R1, and not only this, we have actually created an app store. We built an ecosystem, a community, and I invite you to participate. You can download the RAP SDK. You use all your intellectual firepower on AI algorithms, and you can participate in a commercial rollout in the world. So this is a real opportunity here. So data scientists in the room, please lash on to this capability. We have thousands of developers now helping us to really influence real networks. So this is not Python stuff, which runs in somewhere in a simulation. This is real stuff, which is happening in the market right now. So we're actually by TM4 the only vendor currently on one feature set to be end-to-end level 4 autonomy level. So this is very exciting. So what I'm trying to say is, networks are ready. We're not the only ones. Our competitors doing the same thing. Networks are ready, which I think is great. Now, what about devices? Now, we are really here in the holy, in the mecca of device ecosystem, and we have devices. We have now basically two families at the moment. So one is if you own any Meta device, you put it on. Say, hey Meta, what do I see? I use it. My daughter sits in the audience. She always loves because I'm using it to determine what's the wine I like because I have no ideas about wines. I love a specific, Zinfandel is my thing. So I ask hey Meta, what's the one which is closest to Zinfandel? Never fails me. Works really well. So use cases like this, very mundane, but it's working. And then on the other side, we have now emerging also the Orion glasses, which you put on and it navigates you, it helps you with shopping. It's now becoming a reality. And I don't want to dwell on this because you know this, but I want to tell you 3 things which are not really visible straight on. First thing, has anybody of you tried the wristband? Hands up. So, okay, I would expect that from you. So, how's the experience? Is it? It's great. It's enable. Yeah. Sorry. Yeah.
No, it's so easy to just with gestures. You can tweak a lot of things.
Yeah.
Move things.
Yeah.
On the glasses.
It's exactly as I said. So I couldn't believe it first time I put it on because before when you had to engage with 3-dimensional content, you put on your glasses, VR, AR, and you're trying to grab things. We all look silly, kind of grabbing stuff in the void. It never works really. And finally, this is solved. Put it on, trained, doesn't need to be retrained, works on you straight ahead. You literally can scroll through, click through. It's just, it uses basically the neural signature. As you tell your fingers, your brain tells the fingers to move, electric signals go through your veins, and that's being picked up, and that's how it's trained on. I thought it was really magic. So we're getting a new UX there. a completely new experience engaging with three-dimensional content. Really important. Second thing I want to show you is that's, and that's a rumor, we don't know exactly, but Meta at some point realized apparently that, hey, we don't necessarily need the glasses for people to, if people are just happy to talk to an AI agent, why for them to buy glasses? They could perfectly work with earbuds, as they call it. So this is a rumor. I really don't know if that's happening. But you could perfectly imagine a world where you put cameras into your headphones and they give you the very same spatial context. I can ask you, what's the wine I like? Or, what do you see? Agents can work independently. So this is where personalized AI really can take off fairly quickly until the glasses really latch on. So this is a hypothesis of mine. We'll see whether it plays out. But we don't need to change user behavior because everybody has headphones, right? Not everybody has glasses. Everybody has headphones. So therefore, it will be a combo of this device. And the interesting thing is there's a third device here on the slide, which is that I/O device from OpenAI. They acquired that from Johnny Ive, the company, $6 billion. So it must be worth something. We think it will be something people will be wearing like a necklace with a camera, always on, recording your lives. A bit scary, but somehow we got used to this as a society. And, it's analyzing things, giving suggestions, maybe giving you security parameters as well. So it's quite interesting. But the really interesting thing of this device is something else has happened. OpenAI has started to absorb really important apps right into the ChatGPT stream, right? So if I, for instance, want to launch Spotify today, I can do it straight from there. If I want to shop Amazon, I can do it. So zoom forward 5 years, OpenAI or an equivalent app will have gobbled up all the important apps we're using every day, okay? And it turns out we then only have one app left, the OpenAI app or another app. And this app can sit anywhere. Can sit in the cloud, can sit on a thin client like on a watch, can sit on the mobile phone, can sit in the glasses. So suddenly we could actually end up in a world where we're starting to use mobile phones less and less. So this is a hypothesis I have where for the first time I see a 50-50 future where this may emerge. All right, so maybe let's revisit in 10 years' time, see how this plays out. Huge opportunities for us as an industry because the data rates, interestingly, are not impacted. They just go through the roof, the opposite. So it's quite a lot of stuff to be done. Let me move on to the applications, okay? So applications, so normally these are videos which play. I'm not quite sure why not playing, but never mind. And 1 second. Doesn't want to, all right, yeah. On this one here. Okay, we just stay on this one here. So applications, we don't talk enough about this, but the AI now allows us to build anything we want, anything, right? So we've actually transited from an era where we had to go on YouTube, we had to go to classes to just understand what's the art of the possible. That envelope now has been increased almost to infinity within the limit, of course, because if you use agents, you can do a lot of stuff. Who's using Claude Code and or Codex almost on a daily basis? All right, so we have some aficionados here. All right, so very shy hands also among students. That's good. Now, is anybody using it in Ralph mode? So this is a very geeky question. All right, so you should try this. So this is God mode. So I give my agents at night, before I go to sleep, a budget, tell them what to do, put on the batch loop called Ralph, and it comes back in the morning, and it can do anything you want, okay? And one construct there is really an MCP, the Model Context Protocol. And this is quite, normally there's a video here which shows this is Unreal Engine. Unreal Engine powers Fortnite. And what I did there is I connected basically Fortnite with the MCP, with Claude, and I just tell it, build me a game which looks like a flapping bird game, or build me a house, or recreate the UC San Diego campus. And, depending on the complexity of the project, within 10 minutes, 1 hour, 1 night, it just produces you that thing without flaw. It's phenomenal. So we are now able to produce hyper-personalized content at scale, volumetrically, for anybody on planet Earth. Oh, it's really phenomenal. So therefore, it's really for us as an ecosystem to screw this up. It's really for us now. So we really need to get ready, get the devices ready, get the networks ready, get monetization ready, and really kick this off the ground. So super exciting area, really. All right, so what's the network impact? Well, I spent a lot of time on this, including with my good friends here at Qualcomm, really trying to understand, hey, what does it mean from a traffic point of view? And for the first time, I have decoupled downlink and uplink traffic. In fact, I'm currently trying to schmooze my Ericsson colleagues to, from henceforth, publish in our famous Ericsson Mobility Report downlink and uplink separately. Why? Because they're becoming two beasts on their own. The beast before was downlink. I'll do it on this slide. and the new beast which is coming is the uplink. So downlink still increasing. Reason is increasing as well. First of all, people spend a little bit more time on the phones because we use AI. Meta's getting better to feed you the right Instagram feeds. So that's happening. Demographics is still changing. But there's something really mundane there. Barely anybody talks about this. The real reason traffic increases is because people still switch from 4G phones to 5G phones. Only 70% of the US market is on 5G. The other 30% is still on 4G. If you're on a 4G phone and you watch YouTube, so what you people videos in downstream, you get served with HD or UHD at best. FHD, sorry, full high definition. If you go on a 5G, you get UHD or 4K. Right, it's a huge difference. You know, I invite you. I know 4G was before COVID, and the Wi-Fi era at home was in the middle, so you don't really remember your 4G days. But if you go back to your 4G phone and look at your HD video, you'll say, "No, thank you. I want this. I want to go back to UHD." You upgrade to 5G, and this trend so just this is still at 2 to 3x in the United States and 16x in some other countries. So therefore, the increase currently is about 11% CAGR, which is so compounded aggregated growth rate per year, which is exactly in the rate of growth of mobile phone transitions, okay? 3 gigabyte per month per user growth. That's it, okay? And some people say telecom is collapsing because the percentage is going down, the growth percentage. Yes, the percentage is going down because you normalize every year to a higher value. Right? So it's like, look at let's say the pyramids, and you want to walk up 1,000 stairs. It's like at the beginning, as you do a huge step, and as you go to the top, it's a minuscule part, percentage-wise, you still have to do, but the effort is gigantic. It's gigantic. And we design networks not in percentage, we design them in absolute numbers. It's real antennas, real features, real power, real site density. That's really real spectrum. So therefore, forget about percentages, pay attention to this. Telecom's not dying. It's everything but dying. It's very much alive. Now let's look at the beast, the downlink, the uplink. So uplink is growing at 30% CAGR. I've now seen this personally. So one of the CTOs of Tier 1 CSP showed me their dashboard. End of 24 to end of 25, the uplink had increased by about 30%. So uplink still is very minuscule. It's about 10% uplink, 90% downlink. But if the growth remains at 30% CAGR, in about 10 years' time, they will be equal. And the problem is the breathing room with the uplink is much, much less because its interference is limited. You can't do so many things. It's a real problem to get that right. So we see it growing because we have, well, first of all, more downlink, more TCP IP, so there's more uplink in terms of response rate. So we need to talk about this. We also have now augmented reality emerging, more AI engagements, more people asking for the perfect wine from the menu. So things like these, autonomous vehicles coming on, droids coming on, drones coming on, and it's going to be a data tsunami. I don't think we're really prepared for, neither from an algorithmic point of view, portfolio point of view, nor from a 3GPP point of view. So we really need to go back to the first engineering principles and get that right. That's my call for action today. Uplink is our new currency. Let's get it right. Let's get it right and then monetize that properly. So here you go. You heard it today. So we think it's going to be 10x growth over the next 10 years. Just want to show you some real results from the. It's a new slide, actually. So I don't think I'd shown this publicly ever before, but we have done, after we have seen what happens with the uplink with autonomous vehicles, we started to simulate that in our real-world simulators. And it turns out if you run that simulation at capacity, you always keep about 5% of the users unhappy, which is a very normal dimensioning thing. Then it turns out if you start introducing autonomous vehicles into the cell, they're displacing many MBB users, so best effort users, right? In fact, 29 is the number at the moment. I don't have it on the slide here, but I want you to know it is not 2, it's not 3, 29 users. So imagine now you're in San Diego, you're coming out of the concert. In 5 years' time, you're trying to order an autonomous vehicle, Waymo or whatever, a robo-taxi, and they're coming in, nothing works. Nothing will work. Neither your connection nor their connection. It's going to be mayhem. You're all going to walk home. Okay? So therefore, getting this right is hugely important. And we have the graphs here. The graphs show you basically we've done it very diligently. Lower FDD, it's the mid-band FDD and the mid-band TDD band really run on commercial assumptions. So it's scary. It's really scary. So therefore, it is serious, and we need to take 6G basically serious. So I want to spend the last 10 minutes setting the scene a little bit from our point of view on what we think is important in 6G. There are really 3 constituents we need to get right. Spectrum, the actual portfolio, and monetization. We talk, of course, in this audience always about the portfolio issues. So I have a few slides on this, and I think my subsequent colleagues and the keynotes we'll see throughout the day and tomorrow will touch on this so much more. So I don't dwell on this too much, but I want to talk about spectrum a bit. It's very close to my heart as I sit on the advisory committee of the FCC and the board of Ofcom. A bit of around portfolio and monetization. So these are three things to put everything in context. Spectrum. So it turns out that there's a massive shortage of spectrum, and I gave you the use cases. Use cases are real. We're seeing this in commercial networks right now, and spectrum at the same time is typically a 10-year cycle. So we need to start acting today. Operators need to get their act together, talk to the regulator. We as vendors supporting, academic community should support. We just need so much more IMT spectrum. At the moment, the situation is IMT as a consumer, Mischa Dohler has 200 megahertz of spectrum. Why? Even though telco has 600 megahertz of mid-band spectrum, I only have 200 because it's shared between three competitive operators. It's a competitive spectrum space. Mischa has 200 megs as he's outside. I come back home, I latch onto my Wi-Fi, it's 2 gig, right? Government has 2 gigahertz. So we have 200 megs, 2 gig, 2 gig. And we really need to support a huge amount of use cases. And I always argue in Ofcom, I'm saying, if users still need to think, oh, let me postpone this and do this at home on Wi-Fi, we have failed them. It should be a completely democratized technology. People shouldn't think on where and what to do. They just should use these services. So therefore, we need what I call an equalizer, right? So the movie Equalizer. Think about this as Equalizer 4. So we need to get spectrum equalized, okay? And that is really what's happening right now. The administration has recognized this. It's with the bill last year, 800 megahertz are being forced out into IMT at the moment. We don't want to touch Wi-Fi. We like Wi-Fi. Some of the government service will be more efficient and some new allocations will happen. But spectrum, no new spectrum, no 6G. Just forget about it. Okay, so therefore we need that. That's the sufficient necessary conditions to get things off the ground. Now, what about the portfolio? Well, we talk a lot about different principles, and you can read quicker than I can on that circle here on the different features. And I presume we'll hear a lot about this throughout the day. But the principles we should obey to is really make sure. First principle here is standalone. Let's not repeat the mistake we did with non-standalone, where actually 5G was truly rolled out only in 2025. Let this sink in. Before we had a 5G minus epsilon or 4.9G, until you don't have the core network in place, it's not 5G. And I'm not talking about low latency features. I'm talking about uplink carrier aggregation, flexible allocation of resources and uplink downlink. That is only possible in an SA architecture. Let's not repeat this and do core network 5G. Let's go straight to 6G core network. So no 5G, 6G NSA, but only 6G SA. Then it has to be open, it has to be flexible, it has to be autonomous, intelligent, and it has to be, spectrum sharing has to be natively in there, between 5G and 6G, between 6G and other services, et cetera, et cetera. So these are three guiding principles. So what we then looked at is a little bit the ability to I just want to give you a few use cases. These are snippets. So, our public 6G DIC in Ericsson, is like 200 pages long. I had to pick 3 slides. So I picked 2 and I did a third one. So I picked one here because uplink is really our new currency. We need to do so much more to get this right. The first cornerstones are being set in 5G, but we really need to get this right at very, very high efficiency in 6G. So let's look at the left one, which is decoupled up and down. I co-invented this actually in 2014, and it's now really getting into the portfolio. So the idea is to say, okay, so the uplink we're going to put on the lowest carrier possible, and the downlink we put it on a higher carrier. Why? Because the mobile phone transmits at much lower power. It has a 6 dB power difference. So whilst your downlink says, oh, I have fantastic coverage and capacity, your uplink doesn't even reach the base station. And 6 dB with real channel models translates to about half of the range. Half of the range is 25% of the area. 75% of the area is actually lousy. Is a really lousy uplink. We didn't have the problem today because we are not stressing the uplink, but you have seen the examples, it's coming. So therefore, decoupling this allows us to do much more flexible. In fact, Singtel did it very smartly. They're putting their premium business users only on the below 1 gig FDD carrier for the uplink. So they have perfect uplink everywhere in Singapore. Singapore is small, so maybe not a good market example, but operators starting to realize this. So decoupled uplink and downlink, we need more innovation here. We need more capabilities there. Couple this into proper carrier aggregation, couple that in proper interference and mitigation, et cetera. So that's all there. So we have then the coverage sorted. Let's go to capacity, which are the last two columns here. From a capacity point of view, you can introduce additional uplink slots. Well, it sounds very simple, but the moment you introduce an uplink slot from Mischa's phone to the base station, I'm screwing up somebody else's connection in an adjacent cell. So either you get interference cancellation right, really at a very deep level, or you do some macroscopic orchestration, or you invent something new. I'm looking at Robert here, not this in the room. Please work on this. We need really that dynamic flexibility, because really we want to end up in a completely dynamic state, which is the utmost right column there, where you do completely dynamic allocation and uplinks. So it's called flexible allocation, uplink, downlink. Maybe you want to protect one of the uplinks, et cetera. So a lot of innovation needed there. Now, about latency, the other two columns here, column 2 and 3, is all about latency. So here the idea is let's assume we have one carrier which has a certain TDD pattern, and we have another carrier which has a certain TDD pattern. Rather than aligning them and have, let's say, one uplink, 3 or 4 downlink, your uplink needs to wait until the next TTI comes along. So what we're proposing is, why don't we shift that, right? And therefore, my uplink maybe maximum has to wait just 1 resource block, 2 resource blocks, depending on how you configure that, and you get a much, much better uplink latency, right? So these are the things we're working on. Same problems, okay? You do that, you screw up somebody else in adjacent cells. So we need to get that right. So that's really what it is. And of course, sub-band full duplex is one of the methodologies. My call for action, though, is, let's see if we can do full duplex. So full duplex, the problem is, how do you separate up and downlink in the same band, same time? You need at least 90 dB separation to avoid the ringing. We can do it on narrowband. We've done it for 25 years. We don't know how to do it on wideband. Or maybe we do. So we'll see. Some people know, some people don't. A lot of challenges there. I know it's doable. So therefore, my call for action to you is, innovate on this one and come up with good things. Is that just Hans? Is that a convincing slide for you to say, okay, let's take uplink seriously? Is that good? Okay, all right. As long as John is nodding, I'm good. If the senior vice president of Qualcomm says that's the way to go, then that's good. All right, brilliant. Okay, next slide is just a quick one. You will be very, very familiar with this one. So how can we use AI to improve, let's say, channel estimation so that we can diminish the density of pilot signals? And we started originally to just augment the original pilot signals with some AI. So that became then our kind of blue curve there, a dark blue. And then we just started to sparse the channel estimation density of the pilots. And it turns out AI is just really good, particularly if you do it in an iterative way, to understand how that pilot should look like and do the channel estimation such that aging is barely noticed. So with that, we're able actually to push the throughput by 25%, because pilots take a lot of time frequency resources. Just to do that right is quite significant. I think the significance of this slide here is really, this is not an academic exercise. This is actually measured in our portfolio. Right? So this is like real stuff, which works in edge cases, which is the most difficult thing to cater for anybody who's rolled out real networks. That's a big challenge. All right. So therefore, that's good. Now, my favorite topic, though, is this one here. It's all about what I called originally in 2018 self-synthesizing networks. I think that's the holy grail of telecoms, in fact, of any industry. So when transformers came out, I realized, oh, wow, there's a real opportunity, for us to design networks using AI. So not networks for AI or using AI in networks, but actually use AI to design them. I called it self-synthesized networks. We got very good results with my students in 2018. I switched to Ericsson, had to onboard, COVID happened, et cetera, et cetera. But now, my good friend Kaushik from Princeton actually published something really interesting in December last year. It really shocked us 2 years ago by saying, hey, we can use AI to design RFICs. RFICs are very complicated. It's a very difficult Maxwellian stuff which needs to be solved, green equations, et cetera. So he just threw it at an AI and it came up with phenomenal results. themselves. Tommaso is doing that. I know you guys have started doing this. Let's put it all together, and we can imagine a future where AI is actually helping us to come up with very, very non-intuitive problems, right? So self-synthesizing networks, please work on that. So from a monetization point of view, we kind of realized there's opportunity as well. Get it right, there's just a consumer lab report which came out that's maybe more for the industry right here. I've bundled that into 3 different bundles: differentiated connectivity, monetizing pain points, and most importantly, getting our networks API ready. Because in the future, we will have a model context protocol with an AI agent attached, which has to figure out how can I provide the best 5G and 6G connectivity for my application. It will not, there's no human involved. It won't care what it uses. If it's discoverable, it will use it. And it will pay a penny for a minute for the API call, just as the developer ecosystem works, right? So therefore, get the networks ready and get it going. Of course, traffic will change, profiles will change, etc. So to conclude, really, my call to action is let's get that right. Let's AAA our industry. I like to use the term AAA because it refers to AAA batteries. We use AAA batteries to recharge our domestic devices. So let's use AAA to recharge telecoms, okay? You leave the networks to us. We need your innovation to help us there. The market's competitive enough between Ericsson, Nokia, Samsung, etc. We'll do magic. 6G will be fantastic. Just as with 5G, actually. I can talk in the coffee break why. But yeah, that's a vendor thing. We really need innovation, on the AI capabilities. This is scale. This is ability to come up with new, more efficient and effective telco use cases. We need more help on the APIs. We need more help on AR or the whole device ecosystem. These are really golden times for us as a telco ecosystem. And I think if we get it right with your help, this is going to be good edge going forward. I'll leave you with that, and hopefully it's a good stage for the day to discuss and have a good reason to really march into the 6G era. Thank you very much.
I have a question. Mischa, I don't need why are cars using so much data? I thought they have autonomous sensors of cameras and radars and all of this, and they, of course, they need some data, a little bit of data, GPS or other things, or location. But you are implying that cars are using immense amount of data. Why?
So currently, the majority is because of training stuff. Okay, and this is not a sustainable way forward. So we're not dimensioning the uplink for that use case, but it's factually happening. There's a difference between the car brands. So Waymo is way ahead, so they don't do this anymore. But new cars like Tesla's Robotaxi, as an example, they still want to collect a lot of data. Now, the majority of the stuff is being offloaded with a cable or Wi-Fi once they come back home in the garage. But some of the corner cases are being offloaded immediately because there are some hairy kind of design scenarios which something happened and they really want to retrain the model almost instantaneously. So that's the one reason. Short term, but still a good market. Now, as we move forward, turns out that think of the car now, an autonomous device, like an airplane. There's a black box in there. And something may happen. There might be an accident, and the hard drive might be erased. So insurances are starting to ask for critical data to be offloaded almost instantaneously. It's a much lower rate, and again, probably very specific use cases are being prioritized over others, but this is driving quite a bit of traffic. And then the general telemetry actually is not negligible. It goes anything between 0.5 meg to 1 meg. And whilst 10 cars a day transmitting uplink at 0.5 megabyte per second is a huge amount of traffic. We're not prepared for that. And now if we want to scale this out, it's just not going to be possible. So these are the main reasons. Yeah. Does it answer your question? Okay, good. Thank you.